this video we will discuss the problem earthquake and the paint shop. The problem says that Geek's Paint Shop is one of the most famous in the geek land. But in 2014, earthquake has caused some disarrangement of the items in his shop. So basically we can understand one thing, that Geek had a shop, Geek has a shop basically, and he had some items. He had some items in his shop. Now, after the earthquake, what has happened is some items have lost their position, right? Some items have got disarranged. Each item in the shop is a 40-digit alphanumeric code. So every item has a 40-digit alphanumeric code, right? After this, he wants to retain the reputation of the shop. So to retain the reputation of the shop, he has to arrange all the distinct items in lexicographical order. So your task is to arrange all the items in lexicographical ascending order and print them with their count. So if we will look at the very first example that has been given here, if we look closely into it, then we can observe that this particular code that starts with 1 2 3 4 5 6, this particular code, this particular 40-digit code is occurring only one number of time, because you can see that this it has been given in array, the items. So you can see that this particular code 1 2 3 4, starting with 1 2 3 4 and ending with CBA, it is occurring only one time, right? So in the output it is expected that we return this particular alphanumeric code along with the count as 1, because it was occurring only one time. Now after that, if we will see this particular code, that is 2 3 4, starting with 2 3 4 and ending with CBA again, if we see this particular code, so you can see that it is occurring two times. So since it is occurring two times, so we want to return this particular code with the count as 2, right? And another thing that we need to observe is that lexicographically, that means in ascending order, whichever code is before that we need to put first, and then along with that we'll put the frequency, right? Because if I have some item, suppose if I have some an item A with the frequency as 3, an item let's say D with the frequency as 4, an item B with the frequency as 2, suppose, right? So I'll put first of all item A with frequency 3, then B with frequency 2, and then D with frequency 4, right? So according to the lexicographical order or the ascending order, I'll put the elements, right? I'll put the commodities. So how can I do it? So basically one thing that we can understand is we want to count the frequency. So when we want to count the frequency, then one data structure that comes to our mind is nothing but the map data structure, or you can say the hashing approach, right? But if you will talk about C++ or Java, if you will use the normal map, that is the unordered map, if you will use it, in that case what happens, the keys are not present in sorted format, right? So that will not be used, because if I say that okay, D is occurring two times, if I say that okay, A is occurring one time, if I say that okay, let's say something like C is occurring four times, so if I'll store in the unordered map or in the hash map in Java normally like this, then in that case the keys will be present like this. First of all D will be present, then A, and then C. So this is not going to help us, okay? Instead of this, what we can do here is we can use the map, normal map, that is map of, let's say, string comma int, right? And similarly in Java also we can use the corresponding data structure that helps to keep the keys that we are having keys in sorted format, okay? So what we will do here is we'll simply use a map that will help us to keep the keys in sorted fashion. Let's say if you have D with the frequency as 2, A with the frequency as 1, and C with the frequency as 3, when you will store this inside a map, then actually what will happen, when you will store it in a map that is ordered, that has the keys sorted, then first of all A will be stored with frequency as 1, then C will be stored with frequency as 3, then D will be stored with frequency as 2. So that is how you can do what, now you can return it in form of a packet, that is A with the frequency is 1, C with the frequency is 3, D with the frequency is 2, right? So this is what you can do with this particular thing. Similarly, what you will do is you will simply here store what, you will simply store the code along with the frequency in the map, and based on the lexicographical order or the ascending order of the code, the map will help you to get it sorted, right? So now let's quickly try to write the code for this approach and see what will happen here. Also one more thing, if we are using the map here, then the overall time complexity, if you are using a map that is helping to keep the keys as sorted, then the overall time complexity is going to be nothing but order of n log n. And since we are using the map extra, so that is why the space complexity in the worst case, the space complexity is going to be order of n as well, okay? Now let's try and compile, like write the code and see how it goes. So what we'll be basically doing here is, if you will see, so we have to return what? We have to simply return the vector, or you can say array list, in alphanumeric format. So before discussing it, let's first quickly declare the map and quickly find the frequency of each and every code that is present. So what I'll do here is I'll simply iterate through the string. So let's say for auto I is to let's say a. So I'll iterate through this particular array, like array that has the strings stored. I'll iterate through it, and I'll increase the frequency of each and every string that is present in this particular array A. Once I've done that, so you'll observe that we need to return the answer in terms of vector alphanumeric, right? So what we'll do is we'll declare vector alphanumeric. So the data type, you can understand, it is defined by the user. It is alphanumeric, and let's name it as result. Now what we need to do is we need to simply iterate through the map. So for auto I is to MP, if I'll do, so in that case, what will happen is I'll be able to iterate through the map one by one. Like if you will see here, if suppose that this was stored, ACD was stored, then first of all I'll iterate through this pair A with frequency 1, then C with frequency 3, and D with frequency 2, right? So that is how my I will indicate. So you can see that A1 is stored, suppose, then the first part will indicate that particular string, that particular code. Obviously the code will be 40 digit here, right? And the second part will denote the frequency, that is the count. Now if you will see, so I need to return it in form of alphanumeric, right? So what I will do is I'll simply declare first of all a type that is alphanumeric. So alpha, we'll first of all declare alpha, then numeric. Okay, we'll first of all declare alphanumeric, and we'll have it x. So we'll declare a variable, basically we can say, that will have the type as alphanumeric. And in that, what we'll do is we'll say that alphanumeric dot name will mark it as nothing but I dot first. That is the first part of the map. First part is containing the name, so I'll store it in x dot name. That is, x is a alphanumeric value, right? After that, what I will do is I'll say that x dot count. So I'll now need to store the count for the corresponding node. So I'll say that like x dot count is going to be nothing but I dot second. So this is going to be nothing but I dot second. Now once I've done that, so what I'll do is I'll simply put this particular x, that is storing the current code, in lexicographical order, and the corresponding count to it, that is the frequency to it. So I'll simply store in my answer vector, that is of alphanumeric type. So I'll say that answer dot push back nothing but x here, right? That is what I'm going to do. And after doing this, we can simply do what? In the end, we can simply return the answer after it has stored all such pairs in the of alphanumeric type in the answer vector, right? Now let's try and compile this code to see if it works or not. Okay, it works for the samples. Let's try and submit our code as well to see if it works for all the other cases that are there in this problem. So you can clearly observe that our solution was able to pass all the test cases. If you were still till here and you understood the explanation, so make sure to hit the like button, comment down understood as well, and make sure to subscribe the channel. Thank you for watching this video, and keep coding.